They don't understand you. You're from a whole other world, a different dimension. You open my eyes, and I'm ready to go to me.
Hello guys, my name is Muhammad Amin. I'm going to present to you all about our rocket, HORNBILL HP1. Okay, let's get to know our rocket. So do you guys really know how does the rocket works? So I will explain to you all how does the rocket works based on our rocket model. So the rocket are governed by Newton's law of motion. The first law describes how an object acts when no force is acting upon it. So when the rocket is standing on the launching pad before its launch, it will stand still until an external force is applied to it. Once it's set into motion, it won't stop or change its direction unless and until an external force is applied. Now comes Newton's second law of motion that tells us that the heavier an object is, the more force that required to set into motion. So if the rocket is small and weightless, it requires less amount of fuel. That's why we built the rocket module small. For the rocket material, for the frame, made up by a component of aluminum and titanium, that more lighter. For body is consist of carbon fiber and aluminum coated with nickel, chromium and yttrium as it helps to protect HB1 against high heat. So now comes the Newton's third law, whose principle apply more prominently on the working of rockets. The third law said that every action has an equal and opposite reaction in a rocket burning fuel create a push on the front of the rocket. Launching it forward, this creates an equal and opposite force on the exhaust gas backward. To launch the rocket upward at high speed, the fuel plays the most important role. Instead of using propellant, in HB1 rockets, the gas produced by burning methane gas stored inside the fuel chamber of the rocket. This stored fuel is burned mixing with oxygen gas. The hot gas shoots out from another to the nozzle and the thrust push the rocket upwards, creating a tremendous amount of momentum. This is called jet propulsion. So the main question is that possible the rocket launch failed? But is the thrust produced enough to launch of the rocket? Well, sometimes the thrust produced is not enough and fails to lift the rocket, and sometimes the rocket is explode. And to overcome this failure, certain steps are followed that we apply in HB1. So first, the head shape of the rocket. The head shape, we use nose cone that designed to minimize drag and stability and control, to keep it pointing in the right direction without wobbling. In our rocket, have high-tech control system in guidance system that have navigation and control system to include that include sophisticated sensors and board computers, radar, and communication equipment. This part has two main roles during launch of the rocket. First one is to provide stability of the rocket and to control the rocket during maneuver. The second thing is propulsion system. As I mentioned earlier, we use methane base in fuel because methane is higher performance than other fuels and more lighter. It's also low cost, means the total of cost of launching can be broken down. Based on Falcon 9 project, it use the same fuel and be able to not explode while launching for the first 30 seconds. And the next thing is oxidizer, is to burn methane fuel. And for the fuel pump is powered by electrically powered, and so all of the input methane-based fuel is directly burned in the main combustion chamber. And for the shape, we use small diameter, so can decrease air resistance. So the next part is the nozzle. In our model, contain 4 nozzles in HP1, so that can expand and accelerate combustion product to high supersonic velocity. And fins are used on smaller rockets to provide this stability and control direction. It works in the same way as placing feeders at the tail of an arrow. The greater drag on the feeders keeps the tail of the arrow at the back, so that the point of the arrow travels straight into the wind. To understand how to place fins and how large to make them, it is important to understand about center of mass and center of pressure. For our rocket, we use smaller fins because of our rocket model is small. And after all of these stages being followed, that the main engine start working and helps the rocket to move further into the orbit. After consuming its fuel, it can lift up the rocket up to 28,000 km/h far into space. In addition, to overcome the gravity of the Earth, a rocket needs to travel at a speed of 7 miles per hour. And for our rocket mission is to observe the space, because the space is really big and have a lot of things to be explored. Yeah. And to do research on the outer space on the spot, because we do this, because we do the research out of the space, so it close to the thing that we want to research. Not close enough, but still close. And to be able to travel through space with no difficulties. And the last one is to find a suitable planet for humankind to live on. It's not possible because they still have a lot of planets that we not explore yet. So yeah, that's all for me. Thank you for your attention, and yeah, see you next time.